everyone, my name is Xinyun Zhuang. I work with LinkedIn as a performance engineer. Today I'm going to talk about how to use a software we have built. The software is called Naarad. So as performance engineers, we oftentimes are faced with vast amount of data. For example, we have GC logs, operating system data like CPU usage, memory usage, disk level I/O usage, and so on. And we really want to have a tool to plot and analyze this performance data. Naarad is such a tool. It is built by LinkedIn performance team to help the performance analysis and investigations. It is already open sourced to GitHub. You can download the software, try it out from this link. So GitHub LinkedIn/Naarad. So it has detailed instructions about how to install the software and how to run them. And specifically, we have a wiki page demonstrating how to use this software to plot and analyze the data. So today I will demo about the usage. So firstly, Naarad can plot multiple types of metrics. So these metrics are captured in separate text files. I can show you here. One type of file is a GC log, the Java GC log. So people must be very familiar with them. The second type of log we can Naarad can plot is a Linux system log. For example, reported by SAR utility. So here I have a sample log called SAR CPU usage. It's very standard. The third type of log is gmeter log, like this. And finally, it can plot some other type of metrics. These metrics can be pre-processed and simply written in CSV format, like this. So here I have a CSV file called latency.csu. It contains a timestamp and then some metrics. So each of these metrics is represented by a column. So the second column, for example, is latency. The third column, it can be size, whatever you defined. For this particular example, is the drop rate. Okay? So once you have these metrics stored in separate files, then you decide what metrics you want to plot and analyze. Normally, you put this into a configuration file. I have several configuration files here. Let's start with a very simple one. So I have test SARS-conf. So here, I only define one metric. It's called SAR CPU usage host 1. It takes the input file, which is the file name, and you can also specify the time range using tsstart and tsend. So if you specify that, Naarad will only plot and analyze the data within this time period. And finally, you can choose one graph library to plot them. So for this example, we use matplotlib. And to make this non-trivial, I have another configure file called multiple. So here I defined three metrics. The first one is the same as what we talked about. The second one is Java GC log. So because GC log can be very complex, it has other submetrics. So we can specify what submetrics we want to plot. For example, application stop time, and used the heap space, and so on. The third metric is a latency metric. So here we have the input file, we have the separator of the columns, which is the comma, and the column names, which is the latency and the drop rate for our example. Once you have this configure file ready, you can run Naarad. So here's the format to run Naarad. Naarad-c takes the configure file, configure, test multiple configure file, -I takes the input directory. So inside this directory, you put all the log files there. Okay? -O is the output directory. Eventually, after Naarad run, it will output everything into that directory. The output is in HTML format as well as a lot of figures. So here, the first page normally is the summary page. We have multiple metrics defined, SAR, latency, and GC. Okay? For each metric, we can also specify what submetrics are critical. The summary page will show them. For this particular example, we define the user CPU time, and system CPU time are critical. So for each of these submetric, it calculates the mean values, the standard values, the percentile values, the min, max, and so on. And for each metric, we also have detailed report. For instance, for the CPU usage, we have all the submetrics here, like steal time, I/O, wait time, and we also have all the statistics for each of these submetric. And for each submetric, we have a plot also. The most interesting part is the third part, which is called a chart. Basically, it allows us to correlate multiple plots, and this will greatly help us when we try to root cause the performance bottleneck. For instance, I want to correlate the Java GC pause and some other metrics. For instance, is the allocation rate, right? So we see some big GC pauses here, and want to know what happens to other metrics. They are time correlated. We can drag, zoom in, and zoom out, and so on. So Naarad can also be used to incorporate the SLA definition. SLA stands for Service Level Agreements. So, for example, if you want to run a performance test, right, we want to know what is the result when compared to the SLA. For instance, the latency cannot be certain millisecond. So if the run meets the SLA, we should know the performance run succeeds. Otherwise, the performance run fails. So I have an example here. Again, we put the SLA and the configuration into a file. SLA configure. So to make it simple, I only consider one metric called latency. So here we have a input file, separator columns, column name, and the SLA. The latency SLA equal to mean means the average value less than 9 milliseconds and 99 percentile value less than 10 milliseconds. Okay. We use the same command to run Naarad with the input file and the configure file, and eventually it will have this report. For this report, because we defined two metrics in the SLA, remember the latency mean value and the latency P99 values. So for the mean value, we want it to be less than 9 milliseconds. Unfortunately, the performance run has the value of 8.7 milliseconds, so it is less than 9 milliseconds, so it is showing in green. For the second SLA metric, because we want P99 values to be less than 10 milliseconds, unfortunately, it's 13.8 milliseconds, so it fails the SLA. That is why it's showing in red. And Naarad can also be used to compare two runs. So this is where a common use case, right? You have some base run, and then you make changes to whatever software, and you have a second run, the new run. You want to compare to see what's the performance difference. Naarad can make this task simple. So here, let's say I have two runs, test SAR conf configure and test SAR 2 configure. So each of these configure files corresponds to a run. The SAR configure is the base run, and this is the new run. Okay, so how to run Naarad? to compare these two runs is very simple. Naarad does D means diff, and you give the output directory of these two runs, output star output star2, and again you specify output directory out. And after the run, you will see this report. So for each metric you want to compare, it has the difference between these two runs shown in the table as well as in the figure. For instance, for the guest CPU usage, it shows the difference of all these statistics like the max, min, 99 values. It can also show the relative values versus the absolute values. Okay. Naarad has some other features, so check that out. And remember, we keep incorporating new features into that. So if you have suggestions, let us know. Thank you.